Good morning, students, and welcome to today's class. Today we are taking you on chemistry, and we are continuing from our previous topic, electrolysis. So quickly, we want to tell you about Faraday's laws of electrolysis. Faraday, known as Michael Faraday, a scientist from the years 1791 to 1867, proposed laws on electrolysis. These laws are two. So today we are taking on the first law, but before we go straight, let's give you the assertions he made on these laws. Quickly, he said that this law, Faraday's laws of electricity, says he asserts that the amount of an element obtainable during electrolysis depends on three factors. These three factors are enumerated here. What are the factors here? First, the amount of time for which the steady current is supplied. So for the electrolysis to take place, you need to talk about the amount of, the time taken for what a steady current to be what? To be supplied. Time, very, very important. Next is the magnitude of the steady current. What do we mean by magnitude here? We mean the size of the current, the quantity of current flowing through the what? The electrolytes. Very, very important. Now, next is the charge on the ion of the element. The charge, very, very important. The charge. So these three factors are the assertions he made on electrolysis when proposing the law of electrolysis. Now, the first law of electrolysis proposed by Michael Faraday states that the mass of a substance liberated at an electrode during electrolysis is proportional to the quantity of electricity passing through the electrolyte. I'll take it again. I said Michael Faraday's first law states that the mass of a substance liberated at the electrode during electrolysis is proportional to the quantity of electricity passing through the electrolyte. Remember, I told you previously on electrolysis about what an electrolyte is. I told you an electrolyte are molten ionic compounds in form of ions that conduct electricity. So they said, the law says that the mass of that substance liberated at the electrode. What are the electrode? The plates or the rods used in conduction of what? Electricity in an electrolyte. So that the mass of that substance produced during electrolysis is proportional to the what? To the electricity passing through the what? Electrolyte. Now, the quantity of electric charge that is passed through the electrolyte can be calculated using a very simple formula. Q is equal to I times T. Q there stands for the quantity of electricity passing through the electrolyte, while the I is the what? Is the current. And this quantity of electrolysis, the quantity of current passing through the electrolyte is measured in coulombs. The quantity of electricity passing through the electrolyte is measured in what? Coulombs. While the current that is being passed is measured in amperes. And then the time there is in seconds. So, rightly stated here, I said I is in current and time in seconds, and then the quantity in coulombs. But also, by Michael Faraday, he said that one Faraday is equivalent to 96,500 coulombs. He said one Faraday is equivalent to 96,500 coulombs. So that means for every 96 2,500 coulombs is 1 Faraday. So, and this law was made in honor of what? Faraday, Michael Faraday, as I said. So, quickly, we want to take an example on the first law of electrolysis proposed by Michael Faraday. So, we have an example over there. We also have another law, second law, but we are concentrating today on the first law of electrolysis proposed by Michael Faraday. So quickly, we're going to be taking you an example, and the example here said, what is the quantity of electricity produced by a current of 2 amperes flowing for 5 minutes? Now, if you look at that question very well, you notice that the current flowing through the system is 2 ampere and the time there is 5 minutes. The first thing you need to do is to bring out the formula, that is quantity of electricity flowing through an electrolyte is equal to the current times time. Remember that the time is usually measured in seconds. Very, very important. So, but in that question, the time is measured in minutes. So we need to convert the minutes to seconds. How do we do that? Time is 5 minutes. You ask yourself this question: how many minutes makes a second? And that is, for every 1 minute is what? 60 seconds. So what do you do then? You multiply 5 by 60 to get what? It in what? In seconds. How? Just tell them 5 multiplied by 60, and our result will give us 300 seconds. So now we've succeeded in converting 5 minutes to what? To seconds by multiplying by 60. Next is just to multiply that time in seconds with the current flowing through the what? Through the system. How do we do that? Tell them that the quantity is, what is the current given in the question? The current given in the question is 2 amperes. So you write 2 multiply from here by 300 seconds. That is 300 seconds. And 2 multiply 300 will give us 600. Now, our result is 600. But what is the unit for the quantity of electricity flowing through an electrolyte? The unit, as I told you earlier, is what? Coulombs. So you just write 600 C, and there your result is clear. I hope you got what we've done. Okay? Alright, we have another example here to add to the previous one, and the example states that a solution of copper is electrolyzed for 16 minutes 40 seconds using a current of 0.5 amperes. Calculate the quantity of electricity passing through it. The question is clear. You are given the time with which the copper is electrolyzed, and you're also given the quantity, you're also given the current that is passing through that what? That electrolyte. So, and the electrolyte there is what? Copper. So quickly we do the same thing. Employ the formula. How? Quantity of electricity is current multiplied by time. I told you previously that your time needs to be in seconds before you can work on. So you need to convert the 16 minutes 40 seconds to seconds. Now watch me as we do that. To do that, tell them rightly that time is, how do I convert 16 minutes 40 seconds to all in seconds. Very simple. First, do the same thing. Convert 16 minutes to seconds and then add 40 seconds to it. Your result is clear. So how do I do that? I simply say 16 multiplied by 60. I'll have a result. 16 multiplied by 60 class remains 960. So if 16 multiplied by 60 is 960 and this is also in seconds, I need to add the remaining 40 seconds that is there. So if I add 40 seconds, my result automatically becomes 1000 seconds. So 1000 seconds are in 16 minutes 40 seconds. So to do that, we continue. We've gotten our time all in seconds. Next is the current flowing. Remember initially that I said the quantity of electricity is equal to the current multiplied by the time. Simple. Just tell them quantity of electricity, current, and our current is what? 0.5 multiplied by time, that is 1000 seconds. And class, if I multiply 0.5 by 1000, my result is 500. That is 500. But the unit for the quantity of electricity flowing through an electrolyte is in coulombs. So 0.5 times 1000 is 500 coulombs. And this is the quantity of electricity flowing through that copper electrolyte that is there. So with this class, we've come to the end of today's class. Your assignments will be on your lesson note. Ensure you do your assignments and submit appropriately. We wish you a very happy stay at home and stay safe positively. Thank you very much.